This is a recap for Thursday, April 8th. What we did today was finish up CAMI week 24. So we started on page 3, and we'll erase a little bit what we did and redo it for you. So let's look at problem 1, and the question is, tell whether x and y show direct variation. So the thing to pay attention to is that this is a point, 0, -2. So that's this point right here, 0, -2. And this is 1, 1. And so that's 1, 1. This is 2, 4. This is over 2 up 4. This is 3, 7. That's over 3 up 7 is what that means. That's that point right there. And if we connect those with that blue line that you see right there, it doesn't go through the origin right here. It doesn't go through 0, 0. So then we put on here no. Wow. Okay. Let's erase that. And we put no. That does not show direct variation because it doesn't go through the origin. And let's clean this one up a little bit and see why we put yes. So this is the point 1, 4. That means over 1 and up. Whoops. Let's erase that. Eraser. Didn't seem to want to erase, but that's okay. All right. So what we were doing is going over 1 and up 4. And it seems like it's kind of locked up here. So I'm going to actually go out, come back in, and we'll see if we can restart this. If not, I'll start the video over, but hopefully we can. There we go. I think we're good. So this was the point 1, 4 over 2 up 4. And then the point 2, 8 means that we go over 2 and up 8. And all we really need are 2 points and a pattern. We can notice that this is 1 times 4, this is 2 times 4, this is 3 times 4, whoops, I wrote 2 times 4, 4 times 4. So we have this multiplier of times 4, and it goes through 0, 0. So that's why we put on this one yes. So let's put on this, we'll put yes. And then let's look at the last one. And that is down here. Let's see if we can erase this line right here. There we go. Okay, so I plotted the points right here, and it looked like maybe it was going to be direct variation. It had the point 0, 0, and it had this pattern that it seemed, but what we couldn't do, we noticed in class today, was we couldn't connect all of these with one line. So I could go through those 3, no problem, but I was leaving that point out. I could go through these 2, but I would be leaving these 2 out. I could go through these 2. I could go through these 2. But I couldn't go through all 4 points in a straight line. So then we had to say, no, that's not direct variation. So we can say on this one, no. Okay, and then I said that this is really 8th grade. So if you want to read through this, that's fine. Writing and graphing direct variation. We want to be able to graph direct variation, but in 8th grade is really where you're going to write the equations. So that's what this is right here. But I did say that I would put the answers to this in a recap. So that's where we're at. We're at the recap. So for those of you that are interested in maybe being in pre-algebra next year, you kind of need to get some of the 8th grade things out of the way. So let's look at this. It says the table below shows ordered pair with which model direct variation. So we know that it has the form y equals kx. Write an equation. So we're going to try to figure out, well, what is this k? What is this multiplier? So 2 times 3 is 6, 4 times 3 is 12, 6 times 3 is 18, 18 times 3 is 24. So we've got our multiplier, so this is y equals 3 times whatever x I have. 3 times 1/3 is 1, 6 times 1/3 is 2, 9 times 1/3. Notice how I can't really use division here. I could, but I really am looking for a multiplier. So that means y equals 1/3 x is the equation. So we're looking for an equation. And on this one gets a little bit more difficult. So if I want to go from 5 to 2, and I have to use multiplication, then we did this one time before this year, but I'm going to do 5. I'm going to look at a fraction. 5 times something, and the 5s are going to cancel out, and 2 is going to be remaining. So what we have is 2/5. So this is y equals 2/5 x. Now let's test this out. Let's try this one. Let's do y equals 2/5 times 15 and make sure that equals 5. 2 times 15 is 30. 30 divided by 5. Let's see, is equal to 6. So let's try another one and let's figure out what our mistake was or see if they maybe have a mistake. All right. So let's try another one. Let's try y equals 2/5 times 10, and that is 20 divided by 4, and that equals 5. So I'm going to demonstrate why this is an error right here, how we can find that that is an error, that should be a 6. And we're going to do it with a graph. Okay, so we've demonstrated that it's y equals 2/5 x, that works. And now we're going to make a graph to show. Let's get a little room here. All right, so let's make, oh, I'd rather have it be black. Let's do black. Okay, so this is my y-axis. This is my x-axis. And I'm going to put these points on here. So this is the point 0, 0. And this is going to be, let's see how I want to do this best. We'll count by 5s. 5, 10, 15, 20. And we'll do the same thing here. But we'll make it a little bit smaller. 5, 10, 15, 20. All right. Well, I'm going to change my mind on that. Let's have this be, I'm going to zoom in here. Let's actually, looking at these numbers here, we're going to have a different scale on the side. This is 5, 10, 15, 20, and this is 2, 4, 6, 8, 10. Okay, so we have the point 0, 0. we go over 5 and up 2. So let's be pretty precise about this. Let's go like this and go. I'll go with green. Okay, so we're going to go like this and like this so that we can make sure that we're, if that was a 90 by the way, we would be perfectly level just like that. And let's go over 10 and up 4. Over 10, up 4. We can get it right there at pretty close. Okay, and then I'm going to make a straight line, or we'll make it purple, and we'll make it through these just like that. Okay, now if I go to 15 like this, then it's going to go over to 6. Oops, I should have made that a little, let me redo that a little bit higher to really show that it should go to the 6. And I've just estimated this distance, but it looks pretty good. So let's go up there and over to the 6. Okay, so it does not go over, 5 would be right here, and that really wouldn't even be very close to the 15. So we can see in our graph that this is a mistake here, and that should be a 6. All right, and that is a recap. Wait, we need to go down here and finish, sorry. If you did this one, let's take a look at it. A truck driver drives for 5 hours at constant speed of 55 miles an hour. Write an equation that shows the distance y traveled depending on the hours. So that's going to be, whoops, y equals, let's try that again. So the distance traveled is going to equal 55 times x. 55, so if x is 1, it's 55 miles. Explain why the distance traveled by the truck driver over 5 hours can be modeled by direct variation. Because 0, we have 0 hours and 0 distance. We could have 5 hours and whatever 5 times 55 is, miles. Or we could have 1 hour, and that would be 55 miles. After 3.5 hours, how far had the truck traveled? So what we're going to do is we're going to do this. Y equals 3.5 times 55. I'm sorry. We're going to do it another way. We're going to do 55 times 3.5. 55 times 3.5. So grab a calculator and we'll do 55 times 3.5 is equal to 192.5 miles. And that makes sense. And looking back at this one, we are supposed to, let's figure that out. 5 times 55 equals, this was 275 miles in 5 hours. Make a graph of the equation in part B. Does it make sense to connect the points? All right. So let's look at distance. So we could do 1, 2, 3, 4, 5, 6, and so on. And over here we could count by 50s. 50, 100, 150. And so we'd have to be just a little bit above that, just kind of estimating where that would be. Maybe right there, and 110, and so on. And yes, we could connect those lines because there are places in between the hours, and he's going the same rate. So let's get a line, and we'll go like this. That looks something like that. Make a graph of your equation in part B. Does it make sense to connect the points? Okay, so yes, it does. Yes, because he is driving constantly. And then draw a graph of the speed of the truck over the 5 hours. Does the graph show a direct variation function? And the answer is no, because the speed would be, if this was, let's say that this was in tens, 10, 20, 30, 40, 50, and it was right about there, then it would just look like this. It would be a straight line because he was going 55 miles an hour and he wasn't going any slower or faster. That doesn't go through the origin. So it's a straight line, but it doesn't go through the origin. There was never a point where he was going 0 miles an hour. Okay, and that is a recap for Thursday, April 8th.